Hello students, welcome to today's practice session, and practice makes man perfect, and I am here today with a new practice capsule that is related to VT graph. So what do you mean by VT graph? That is nothing but velocity time graph. Velocity taken along y-axis and time taken along x-axis. So like this, velocity unit is meter per second and time is in seconds. Okay. Now if you have a graph like this, for example, I have a graph like this. So how to calculate acceleration from this VT graph? Please remember, always slope of VT graph that provides or that gives acceleration. Very important. Okay, so slope of velocity time graph gives acceleration. Okay, now you have a graph here. So how to get acceleration, how to get slope from this? So if you know this particular angle, if this angle made by that graph with x-axis or time axis is theta, then remember slope that is equal to tan theta. Okay, very simple, slope equal to tan theta. Okay, now if you know certain values, how to calculate tan theta? Tan theta is nothing but opposite side divided by adjacent side, correct? So if you have a graph like this, and if you know certain time interval, or if they ask you to calculate acceleration between certain time interval, okay, so if you have time here t1 and here t2, and if you continue like this, okay, so here I will consider velocity as v1, and at this particular point velocity is v2. If they ask you to calculate acceleration between the time interval t1 and t2, then if you know this angle as theta, this should be theta, no? This should be theta, correct? So what about this distance? What about that distance? So this distance is same as that of this distance, no? So here to here we can write this as v2 minus v1. Similarly, what about this distance? That is nothing but t2 minus t1. So as I said, slope is nothing but opposite side divided by adjacent side. So what about opposite side for this theta now? That is v2 minus v1. So v2 minus v1 divided by adjacent side. So for theta, this is the adjacent side. So we can write this as t2 minus t1. So like this you can calculate slope or you can calculate acceleration. Okay, this is actually positive acceleration. So here actually it is positive acceleration because slope is positive. For example, now you have a graph like this. Okay, time and speed. Okay, and you have a graph like this. Now if you have this angle as theta, but please remember, while calculating slope, you need to consider angle like this only. Okay, so you need to consider anti-clockwise direction. Okay, so actually in this case, the slope is negative. Slope is negative because just compare this graph, these two graphs. So here it goes, velocity goes on increasing. That means positive acceleration. But here what happens as time passes? Velocity goes on decreasing, that means negative acceleration, that is retardation. Retardation you will get. Retardation means negative acceleration. Therefore, the slope must be negative. So how to get value of slope from this? As I said, if you know this angle, you need to consider only this angle while calculating slope. So you know the total angle. This total angle, what about this total angle? That is 180 degree. So out of 180 degree, you know this angle as theta. This angle is theta, correct? This angle is theta, that is given. Then what about this angle, remaining angle? Out of 180 degree, theta goes here, so remaining is 180 minus theta, correct? Therefore, we can write slope in this case, that is equal to tan 180 minus theta. So this is how you can calculate slope in both the cases, positive acceleration and negative acceleration. So once you know acceleration, you can relate that with force, no? Because in this today's problem, we need to get the ratio of forces. Therefore, that means if you know acceleration, you can relate that with force. So you have famous equation, that is equal to F equal to ma. That means for a particular body, this force is directly proportional to acceleration, because if it is moving, you can consider mass as constant. For a particular body, that mass is constant. So we can write F is directly proportional to acceleration. So F1 by F2, that is equal to A1 by A2. So if you want to calculate ratio of forces, just enough to calculate ratio of acceleration. So from VT graph, how to get acceleration? That is nothing but slope of VT graph that provides acceleration. So using these concepts, we need to solve today's problem. So let us move on to our problem. Here it comes. So you need to calculate ratio of forces between the time interval AB and BC. The graph is VT graph. So you need to calculate ratio of forces. So as we discussed before, you can relate ratio of forces between AB and BC. So that must be equal to what? Acceleration between AB, ratio of acceleration between AB and BC. Correct? So how to get acceleration from VT graph? That is nothing but tan theta. Therefore, tan theta 1 divided by tan theta 2. So we can consider this from A to B, the angle is given, that is 30 degree. Okay. Then B to C, the angle is given as 60 degree. But as we discussed before, this is actually retardation. Just look at this. From A to D, velocity goes on increasing. That means A to B, acceleration goes on, velocity goes on increasing. That means this is positive acceleration. And from D to C, velocity goes on decreasing. That means it is negative acceleration. Correct? So as I said, if you have this in this problem, given this angle as 60 degree. So as I said, we need to calculate slope. That means you need to consider only this angle. So if this is 60 degree, what about this angle? As I said, 180 minus 60. So 180 minus 60, that means 120 degree. Therefore, this angle will be equal to 120 degree. Correct? So we can rewrite this. So FAB divided by FBC, that's equal to tan, from A to B, tan 30 degree divided by, what about this, theta 2, from D to C, that is negative acceleration, that is theta is 120 degree. I hope it is clear. Okay. So what about tan 30? Value of tan 30, that is 1 by root 3. Tan 30 is 1 by root 3. Then tan 120 degree, tan 120. So how to write tan 120? You must know tan 90 plus theta, must be equal to minus cot theta. Okay, please remember this. Now this 120 can be written as tan 90 plus 30, no? Tan 90 plus 30. This 120 can be written as tan 90 plus 30. That means that is equal to minus cot 30 degree. So what about cot 30? That is minus root 3. Sorry, cot 30 is root 3 and you have a minus sign here. So minus cot 3. Minus root 3. Therefore, this can be written as minus root 3. Correct? So if you simplify, finally what do you get? FAB divided by FBC, that's equal to, so simplify this, 1 by root 3 into 1 by minus root 3. That means minus 1 by 3 is the answer. Correct? So ratio of forces FAB divided by FBC, that is equal to minus 1 by 3. So if you look at the options, yes, here we have, this is not this, so minus 1 by root 3. Correct? Option B is a correct answer, or second option. Okay, not this one. So second option is a correct, minus 1 by 3.